What's up YouTube, welcome to .NET Mob. This is my second video in the series of common 50 C# beginners programs or exercises. In the previous video we have discussed questions from 1 to 10. In this tutorial we will discuss questions from 11 to 20. If you have not watched the previous video, I have given the link in video description. Please go through that. Before starting this video tutorial, I would like to ask you a favor. If you found this video helpful, please thumbs up this video. If you are new here, please be subscribed to this channel .NET Mob. Without further explanation, let's get started. Here we have the first question of this part. 11th question. We need to find a given number is odd or even. So let's look what we have got inside this program. First of all, we will request the user to enter the number, then we will retrieve the user input inside this variable in number. In order to find the number is odd or not, we will use this modulus operator on these operands in number and 2. That means when we divide in number with 2, if we get 0 as a remainder, we can say that this number is an even number. If there is a remainder 1, then we can say that this number is an odd number. Let me run this application. Let me try with an odd number 7. So here we have the output 7 is an odd number. Let me try again with an even number 8. So here we have the output 8 is an even number. Now let's discuss the question number 12 and 13. 12th and 13th question is a follow-up question for this 11th question. So let's look how we can do that. Here we have the 12th question. In this question we will generate even numbers up to a given number. So let's look what we have got inside this program. In this program we have used a different logic from 11th question. Here we have initialized in number and in test with 0. Inside this while loop, on each iteration we will increment this in test with 2. So we will get even numbers from 0 to the given number. We have started from 0 because 0 is the first even number. Let me run this application. Let me input 9. So here we have the output even values up to 9, 0, 2, 4, 6, 8. In the same way we have done the 13th question here. Here we need to find odd numbers up to a given number. Instead of initializing this in counter with 0, we have initialized with 1 because 1 is the first odd number. Inside this while loop, we will increment I and counter with 2 on each iteration, so we can print odd numbers from 1 up to the given number. Let me run this application. I will input 5 here. So here we have the odd numbers up to 5, 1 and 3. Without further explanation, these questions are very simple. Now let's move to the 14th question. In this 14th question, we will discuss how to check whether a number is Armstrong or not. Definition for Armstrong for 3-digit will be like this. Armstrong number is an integer. When we sum cubes of its digits, we will get the same number itself. For example, we have 371. Now we have to find cube of these digits 3, 7 and 1. If sum of these cube is equal to 371, we can say that 371 is an Armstrong number. Cube of 3 is 27 plus cube of 7 is 343. Then cube of 1 is 1. Sum of these numbers is 371. So we can say that 371 is an Armstrong number. For that, first of all, we request the user to enter the input and we will receive the input inside this variable in number. On each while loop iteration, we will calculate the cube of its digits. Finally, we will sum up these cubes inside this variable in sum. If original number in number is equal to in sum, we can say that given number is an Armstrong number, otherwise it is not an Armstrong number. Let me run this application. Let me try with 371. So here we have the output 371 is an Armstrong number. Let me run this application again and I will try a random 3-digit number. So here we have the output 548 is not an Armstrong number. Now question number 15. In this question, we are going to find whether a pair of number is amicable or not. In this 15th question, we have two numbers, or you can say that we have a pair of number. We want to find whether this pair is amicable or not. By definition, amicable numbers are two different numbers so related that sum of proper divisors of each is equal to the other. For example, here we have the smallest pair of amicable numbers 220 and 284. Proper divisors of 220 are 1, 2, 4, 5, 10, 11, 20, 24, 44, 55, 110. If we sum these proper divisors, we get 284. That means second number. Now find proper divisors of 284, which are 1, 2, 4, 71 and 142. If we sum these divisors, we get 220. That means the first number. So this is the relation between two numbers inside an amicable pair. Now let's check what we have done inside this C# program here. First of all, we request the user to enter the two numbers. We receive the user inputs inside these variables in number 1 and in number 2. For this program here, we have an extra function test. It has two parameters a and b, and it will return a boolean value. Inside this function, we find proper divisors of a, and we will sum these proper divisors. If we get second number b, then we will return true value, otherwise it will return a false value. So here we have called this function test by passing first number and second number. Here we have changed order of parameter passing. Second number is passed as the first parameter. First number is passed as the second parameter. If these two function call return true, then we can say that these numbers are amicable. Let me run this application. Let's try with the smallest amicable pair, 220 and 284. So here we have the output, 220 and 284 are amicable pair. Let me try with a random number, 365 and 625. So here we have the output, 365 and 625 are not amicable. Now let's discuss question number 16. In this program, we are going to find LCM of two numbers. That means least common multiplier. Here we request the user to enter the two numbers, and then we will receive the two numbers inside these variables in number and in number 2. We have to find the least multiplier when we consider the multiplication table of these numbers. For example, here we have 3 and 4. For 3, multiplication table will be like this: 1 into 3 is equal to 3, 2 into 3 is equal to 6, 3 into 3 is equal to 9, 3 into 4 is equal to 12. For 4, multiplication table of 4 will be like this: 1 into 4 is equal to 4, 2 into 4 is equal to 8, 3 into 4 is equal to 12. So here we have the first common multiplier in the multiplication table. So this logic is implemented inside this for loop. So here we have initialized this I variable with the smallest number from given pair. Inside the loop, we applied modulus operator for this I variable with number 1 and number 2. Modulus operator is used to find remainder when we divide two numbers. So here we are trying to divide I with number 1 and I with number 2. If both these division result 0, then we can say that I is the LCM of these two numbers. Let me run this application. Let me try with 6 and 5. So here we have the LCM of these two numbers, 30. Let me try again with 6 and 4. So here we have the LCM of these two numbers as 12. 2 into 6 is equal to 12. 3 into 4 is equal to 12. That's it, simple. Now question number 17. In this question number 17, we are going to find least common divisor, not least common denominator. First of all, we request the user to enter the two numbers. Then we retrieve the user inputs inside these variables in number 1 and in number 2. Suppose here we have two numbers, 12 and 9. First of all, we need to find the proper divisors for this number. For 12 it will be 1, 3 and 4, 6. For 9 it will be 1, then 3. If we go for least common divisor directly, then we get 1, because 1 is the proper divisor of any given number. For that, we check is there any common divisor which is greater than 1. So in this case, here we have 3. For some pairs, we may not have common divisor other than 1. In that case, 1 will be the LCD. For that, here we have declared and initialized a variable in smaller number. It is initialized with the smallest number from the given pair. So here we have the for loop. Iteration variable in test is starting from 2, and then it will increment up to the smallest number from the given pair. Inside the loop, we check is there any common divisor for in number 1 and in number 2 by using modulator operator with in test or iterator variable. If in test is less than or equal to smallest number, then we can say that LCD of this number is in test. Otherwise, LCD of these numbers will be 1. I will try with 8 and 6. LCD of these numbers is 2. Let me run this application again. Now I will try with 5 and 11. LCD of these numbers is 1 because they don't have any common divisor other than 1. Now let's try question number 18. It is just opposite to the 17th question. Here we need to find the GCD of two given number. GCD means greatest common divisor. Here we request the user to enter the pair of numbers, and we retrieve the numbers inside these variables in number 1 and in number 2. And here we have a variable initialized with the smallest number from the given pair. So here we have the for loop to implement program logic. Iterator variable is initialized with the smallest number from the given pair. On each iteration, we decrement this iterator variable by 1. Inside the for loop, we divide in number 1 and in number 2 with in test variable or iterator variable. If both these operations result 0 remainder, we can say that in test is the greatest common divisor of given pair. Let me run this application. Now I will try with 40 and 6. So here we have the GCD of these numbers is 2. Now let's discuss question number 19 here. In this 19th question, we are going to add two matrices of same order. You can assume matrix as two-dimensional array. We define matrix arrays using these terms m into n. M means number of rows, n means number of columns. Okay? M into n is called order of a matrix. Suppose a matrix has 3 rows and 4 columns. Order of matrix is 3 into 4. In order to add two matrices, both of these matrices must have same order. If one has 3 into 4 order, then second matrices must have the order 3 into 4. Then only we can add two matrices or two-dimensional array. First of all, we request the user to enter order of matrix 1. We will store the matrix order inside these variables matrix 1m, matrix 1n. M means number of rows, n means number of columns. Similarly, we retrieve the order of second matrix inside this matrix 2m and matrix 2n. And here we check the condition of same matrix order. If they are same, we can go for addition. Otherwise, we will print the message addition not possible since orders are not same. Now we will ask user to enter elements of first array. With these loops, two for loops, we can retrieve the values of first matrix. And with this second for loops, we can retrieve values of second matrix. Here we will print the first matrix in the two-dimensional array by placing a tab between each column. In the same way, we print the second matrix here. Finally, we will add matrix number 1 and matrix number 2 with elements in same position. Finally, we will print the resultant matrix here. Let me run this application. I'm going to add two matrices of order 2 into 3. Elements of array will be like this. So here you can see the output. Your matrices are as follows. Operand matrix and resultant matrix are displayed in two-dimensionally. So here we have the first matrix and second matrix, resultant matrix here. 1 plus 7 is equal to 8, 2 plus 8 is equal to 10, 3 plus 9 is equal to 12, and so on. Now let's discuss question number 20. In this question, we are going to find multiplication of two matrices. As I told you before, order of matrices are represented like this, m into n. In order to multiply two matrices with order m1 into n1 and m2 into n1, as I told you before, first number in the order will be number of rows. So m1 is number of rows, n1 is number of columns. In order to multiply two matrices with these two orders, m1 into n1 and m2 into n2, there is a requirement. Number of columns in first matrix must be equal to number of rows inside the second matrix. That means number of columns inside the first matrix is n1, number of rows inside the second matrix is m2. So n1 and m2 should be same. Resultant matrix has the order m3 into n3. m3 will be same as m1, that is number of rows inside the first column. Then n3 is equal to number of columns inside the second matrix. This is how we can multiply two matrices. First matrix has the order 2 into 3, second matrix has the order 3 into 2. So number of columns inside the first matrix is equal to number of rows inside the second matrix. In order to multiply these matrices, we have to multiply this first row with first column. So we will get the first row, first column inside the resultant matrix. 1 into 7 plus 2 into 9 plus 3 into 11. So 7 plus 18 plus 33 is equal to 58. In order to get the first row second element, we will multiply this row with second column of this second matrix. In the same way, we will multiply second row of first column with columns of second matrix in order to get the second row of resultant matrix. We will store the matrix orders inside these variables: matrix 1m, matrix 1n for first matrix, matrix 2m and matrix 2n for second matrix. Then we will check the requirement to multiply two matrices. If first matrix column number is not equal to second matrix row number, then we say multiplication is not possible since orders are not fit for it. If they satisfy this condition, we will do the multiplication. For that, first of all, we will receive the elements for matrix 1 and matrix 2. Then here we will print the matrix 1 and matrix 2 in 2D. Matrix multiplication is done using these two for loops. I am not going to explain these for loops in depth. Here we are going to do this multiplication, row into column multiplication to get the one element. So that's what we have done inside these two for loops. For better understanding, you can try with examples by putting a breakpoint here, so that you can see what is happening in each iteration. Finally, we will print this resultant matrix in 2D here. Let me run this application. I'm going to multiply a matrix with order 2, 3, then 3, 2. Elements of first matrix 4, 5, 6, 3, 2, 1. Elements of second matrix 9, 6, 3, 2, 5, 8. Here we hit the breakpoint. Now you can see the encounter and related variables for these for loops. We can use this button step into F11. You can literally go through each iteration variables and each steps like this. So please try this so that you can get a better understanding what is happening inside matrix multiplication, because most of us, when we were beginners in programming, matrix multiplication may be a quite complex for beginners. For now, let me remove this breakpoint here and click on this continue button. So here we have the final output. First matrix is printed here, second matrix is printed here, and here we have the resultant matrix. First matrix order is 2 into 3, second matrix order is 3 into 2. So resulting matrix is equal to 2 into 2. In this part we have discussed questions from 11 to 20. In the next part we will discuss questions from 20 to 30. You can download this project source code from the link given below in video description. If you found this video helpful, please thumbs up this video. And for more awesome videos like this, please be subscribed to this channel .NET Mob. Please like and share this video with your friends so that they can benefit from this. Have a nice day. Bye.